The next lesson in Unit 3 is Lesson 5, which is simplifying variables with rational exponents. Simplifying variables with rational exponents. Let's zoom out real quick. All right, the directions will say simplify. Let's take a look at example number 1. I've got x to the 2/3 times x to the 1/3 times x to the 4/3. So even though the exponent on the x, they're all rational exponents, it doesn't mean the rule changes. It still stays the same. When you're multiplying by the same base, which we have, the base is x, you keep the base and you add the exponents. So that's exactly what we're going to do. I'm going to keep that base and I'm going to do 2/3 plus 1/3 plus 4/3. A little bit easier because all the denominators are the same, so add the numerators, keep the denominator. So I'm getting x to the 7/3. All right, so how do we know this is simplified? Well, I know it's not simplified because that base, the exponent, is an improper fraction. So I know that I can take something out. I can break that down. So let's do that. Let's write this in radical form. So if I were to rewrite it, remember this is the root and this is the power. So I've got the 3rd root of x to the 7th. If I were to rewrite that in radical form, that's what it looks like. Now from here, I've got to see how many groups of 3 do I have. Remember, you're grouping by 3 because that's the root. So I've got 7 x's. So there's a couple ways you can do this. You can do the division right in your head, or you can actually write out the 7 x's. If you need to do that, then you do it. It takes a little bit longer to do it that way. But we'll just to show you, I've got 1, 2, 3, 4, 5, 6, 7, and I'm grouping by 3 because that's the root. Now you can do this in your head. You don't need to write this out, but visually that's what it looks like. So I'm going to take out 2 x's, so that's going to give us x squared. 3rd root of what I didn't circle, which is x. So x squared, the 3rd root of x. Okay, let's try another one. Number 2. I've got c to the 4/7 times c to the 2/7 times c to the 1/7. All right, the bases are the same. It's c, so let's keep the base and add the exponents. I'm going to lift that up a little bit. I've got 4/7 plus 2/7 plus 1/7. When I add that up, I've got 4 plus 2 is 6 plus 1 is 7. So for this one, I've got, if you notice, the numerator and the denominator are the same. So when they're the same, they just cancel each other out. We're getting 1. So it's c to the 1st power. If you can divide that out evenly, then divide it. Now suppose you didn't know that. Suppose, I'm hoping you would, but suppose you didn't. If I were to rewrite this, I would have 7 c's underneath. 1, 2, 3, 4, 5, 6, 7. And I'm grouping by 7 because that's the root. What will happen is I'm grouping all 7 together. That's going to come out. And it's not c, the 7th root of blank. Okay, if you group everything together and there's nothing left that's not circled, that radical goes away no matter what the root is. But in any case, our answer is C. All right, let's take a look at one last one where the denominators are not the same. So for number 3, I've got a to the 3/5 times a to the 7/2 times a to the 1/5 as you're adding the exponents here. All right, so the common denominator of 5 and 2 would be 10. It's the least common multiple of 5 and 2. So let's rewrite this with the denominator of 10. Now I need to say to myself, 5 times what gives us 10? 5 times 2, that means I've got to take that 2 and multiply it to the 3, which gives us 6. 2 times 5 gives us 10. That means you're going to take the 5 and multiply it to the 7, which gives us 35. And then 5 times 2 is 10, 2 times 1 is 2. That over 10. Double check that math, looks pretty good. All right, so from here, I'm going to write this in radical form, or you can kind of just divide that out. So if I rewrite that, it's going to be the 10th root of a to the 43rd power. Now, if you want to go and write out 43a's, go right ahead. It's going to take you a long time to do that. Or you can kind of do that right in your head. Think of how many times does 10 go into 43? Well, 10 goes into 43 4 times. So I know I'm going to be taking out 4 a's. So that's going to be a to the 4th. And then I've got the 10th root of, well, 4 times 10 is 40. You're going to do 43 minus 40. I'm going to be left with 3 a's. Because remember, you have to visualize 43 a's all lined up, and you're grouping by 10 because that's the root. In any case, whether you write it out or not, that's going to be your final answer, which is a to the 4th, the 10th root of a cubed. Okay, that was the first part of simplifying variables with rational exponents. The second part of this, I'm going to kind of go like this to kind of break this up. The next part, if we take a look at number 4, I've got a to the 1/3, b to the 4/3, c to the 2/3 times a to the 1/3, b to the 6/3, c to the 1/3. Okay, this one's a little bit different than the first 3 because now we're dealing with 3 different variables. The first 3 problems, the variables were all the same. So for this one, I'm looking for the same variables. So I've got a to the 1/3, because we're multiplying here, I'm taking the same bases and I'm going to add those exponents because that's the rule. So I'm going to take these and I'm going to add them. Same thing with the b's, same thing with the c's. So this becomes, I'm not going to write it out like I did up here. We're just going to add it. 1/3 plus 1/3, that's giving us 2/3. Now I'm going to do the same thing with the b's. 4/3 plus 6/3, that's giving us 10/3. And then 2/3 plus 1/3, that's going to give us 3/3. Now this one I already know I can divide out. I'm going to get an answer of c to the 1st, but let's write this in radical form. Because these denominators have to be the same, because when you're writing it in radical form, I can't have a different root. Remember, this number is the root. It has to be the same. So I'm going to rewrite this as the 3rd root of a squared, b to the 10th, c cubed. Now, I'm going to see what can I take out of that radical. Well, I have to have at least 3 of something because I'm grouping by 3's to take it out. This is an a squared. I don't even have enough. And I already knew by looking at this fraction, because this either has to be the same as the denominator or larger than the denominator to take something out. So this a squared's not going anywhere. It's going to stay right underneath. Now I've got 10 b's. I've got to group them by 3. So it's up to you. If you want to write out 10 B's and group it by 3, you can do that. Or you can just say, how many groups of 3 are there in 10? Well, I know there are 3. So I'm going to have B cubed. I'm going to take out a B cubed. And then 3 times 3 is 9. 10 minus 9, I know I'm going to be left with, well, this A squared is going to be there. And then I've got this B. But keep in mind, you can, I'm just going to do it for this one. I won't do it for the next one. I could write out 10 B's. You want to do that? Go right ahead and group by 3. That's where that B cubed comes from. And then I've got that 1 B that's left. And then I've got 3 C's. This one I don't need to write out. I've got 3 C's and I'm grouping by 3. That's going to give me 1 group. Or I could have just said 3 divided by 3 is 1. And I'm not left with anything else. So our final answer for that is B cubed C, the third root of A squared B. And that's it for Unit 3, Lesson 5.